Download this code from codegive.com, link in the description below. Change data capture, CDC, is a design pattern used to track and capture changes in data, typically in a database, and propagate those changes to other systems or services. This is particularly useful in microservices architectures, where different services may need to react to changes in shared data. In this tutorial, we will cover the basics of CDC and provide a code example to illustrate how it can be implemented in a microservices environment. Overview of change data capture. CDC typically involves the following steps. 1. Data change detection. Identify when changes occur in the data store, inserts, updates, deletes. 2. Change event creation. Create events that represent these changes. 3. Event propagation. Send these events to interested parties, other services, message queues, etc. 4. Event handling. Receive and process these events in other services. Technologies often used in CDC. Databases. Many databases have built-in CDC features, example PostgreSQL, MySQL, MongoDB. Message brokers. Tools like Apache Kafka, RabbitMQ, or AWS SNS/SQS can be used to propagate events. Event sourcing. This architectural pattern can complement CDC by storing all changes as a sequence of events. Example scenario. Let's consider a simple e-commerce application with 2 microservices. 1 order service, handles order placements. 2 inventory service, manages product stock levels. When an order is placed, the inventory service must update the stock level. We'll implement CDC to notify the inventory service about changes in the order service. Step-by-step implementation. Prerequisites. Java Development Kit, JDK. Maven. Docker, for running a local Kafka instance. Spring Boot, for building microservices. 1. Set up Kafka. First, we will set up Apache Kafka to handle our events. You can run Kafka using Docker with the following command. Bash. Docker run dname zookeeper p2181:2181 worstmeister/zookeeper 3.4.6. Docker run dname Kafka link zookeeper zkp 9092:9092 worstmeister/Kafka latest. 2. Create the order service. Create a Spring Boot project for the order service. Here's a simple implementation. pom.xml, add dependencies. XML. Dependencies. Dependency. Group ID org.springframework.boot/group ID. Artifact ID Spring Boot Starter Web/artifact ID. /dependency. Dependency. Group ID org.springframework.kafka/group ID. Artifact ID Spring Kafka/artifact ID. /dependency. /dependencies. Order service application.java. Java. Import org.springframework.boot.spring application. Import org.springframework.boot.autoconfigure.spring boot application. At Spring Boot application. Public class order service application. Public static void main, string args. Spring application.run, order service application.class, args. Order controller.java. Java. Import org.springframework.beans.factory.annotation.autowired. Import org.springframework.kafka.core.kafka template. Import org.springframework.web.bind.annotation asterisk. At REST controller. At request mapping, /orders. Public class order controller. At auto wired. Private Kafka template string Kafka template. @post mapping. Public string create order, @request body string order. / logic to save order in database, omitted for brevity. / send change event to Kafka. Kafka template.send, order topic, order. Return order created. 3. Create the inventory service. Create another Spring Boot project for the inventory service. pom.xml, add dependencies. XML. Dependencies. Dependency. Group ID org.springframework.boot/group ID. Artifact ID Spring Boot Starter Web /artifact ID. /dependency. Dependency. Group ID org.springframework.kafka/group ID. Artifact ID Spring Kafka /artifact ID. /dependency. /dependencies. Inventory Service Application.java. Java. Import org.springframework.boot.spring-application. Import org.springframework.auto-configure.spring-boot-application. @Spring Boot application. Public class inventory service application. Public static void main, string args. Spring application.run, inventory service application.class, args. Inventory listener.java. Java. Import org.springframework.kafka.annotation.kafka listener. Import org.springframework.stereotype.service. @service. Public class inventory listener. @Kafka listener, topics equals order topic, group ID equals inventory group. Public void listen, string order. / logic to update inventory based on the order. System.out.println, received order, plus order. / update inventory, omitted for brevity. 4. Configuration. Add Kafka configuration in application.properties for both services. Order service. Properties. Spring.kafka.bootstrap servers equals localhost 9092. Inventory service. Properties. Spring.kafka.bootstrap servers equals localhost 9092. 5. Running the services. 1. Start the Kafka and Zookeeper containers if they are not running. 2. Run the order service and inventory service applications. 3. Use Postman or any HTTP client to send a POST request to the order service. HTTP. Post http://localhost 8080/orders. Content type, application/JSON. Order ID, 123, product ID, ABC, quantity, 1. 6. Observing changes. When an order is created, you should see the output in the inventory service console indicating that it has received the order event. Conclusion. In this tutorial, we covered the basics of change data capture in microservices using Apache Kafka. We built a simple example with an order service that sends events whenever a new order is created, and an inventory service that listens for these events to update stock levels. This pattern allows for decoupled services that can react to changes in a scalable way, making it ideal for microservices architectures. Feel free to extend this example by adding error handling, persisting events, or using a more complex data structure for orders.